Hi everyone, and welcome to this technical session about Develocity platform. My name is Sébastien Artemat. I'm from the relay team at the Eclipse Foundation. And this presentation is organized in collaboration with Gasper Korek. So I'm very happy that you could join us today for this session, where we will introduce this new platform, Develocity. Gasper will give us a walkthrough on what is Develocity with a live demo, and he will show as well other implementation in open source projects. First of all, before we start, I would like to introduce to our guest, Gasper. So can you present yourself in a few words?
Yeah, of course. So hi, as Sebastian mentioned, my name is Gaspar. I'm based out of Slovenia. I mean, in Slovenia. And yeah, for the last couple of years, I've been helping customers improve their build times as part of the solutions team here at Gradle, which is the company behind, obviously, the Gradle build tool, but the Develocity platform as well, which is kind of the focus of this presentation.
Great. Thank you, Gasper, and thank you for being with us today. So before we get started, I would like to run through the agenda. We have a lot to cover today. First, I will introduce the challenges that Eclipse project and Release engineering team at the foundation face daily with CI builds. After that, I will discuss about the evaluation phase of Develocity, and we will have the Develocity presentation with a live demo by Gasper. And finally, we will dedicate some time for Q&A. For that purpose, if you have any question, please feel free to drop them in the chat. And we will ask a question at the end of the presentation. Note that this session is being recorded and we will be made available afterwards. With all that said, let's jump straight in. Let's get started with the challenges that Eclipse project and the Relang team faced with the daily CI build at the foundation. So as you may know, as a Relang team, we are on the front line when issue arise on the CBI platform or when a project open a ticket on the help desk. And for some common points, we have some common points identified that require significant time and resources for investigation. On both sides, Eclipse project side, because they make their own CI pipeline, etc. But also on the Eclipse Foundation side, especially the Relang and infra team, because we need to debugging and investigate in when a pipeline fails. So firstly, the one is about the slow build identification. As you may know, detecting bottlenecks in the build process is a real challenge. So having metrics on tasks, jobs, pipelines is very important. Even in long term, it's crucial for debugging and see a slow build and over the time. And without clear metrics and monitoring, it's really easy to struggle and to understand how CI why CI fails and why there is issues in CI. Next point is about build performance visibility. We have internal tooling that not yet exposed to everyone. That's planned in the future. So projects have to request for such metrics. I mean, CPU, memories, network traffic, etc. However, it's not enough. In some cases, projects still have to implement their own metrics within their CI, or print statistics, or print variable, etc., to debug their own CI. So that makes even harder to debug. The next one is build failures and flakiness. This is an important one because it reduces confidence in CI services and it causes by causing a lot of unnecessary debugging efforts. And the last, enhancing pipeline efficiency. So at the Eclipse Foundation, projects are provided with resource pack. And that comes with a limited allocation of CPU and memory for each project. This means that build run in a constrained environment while also sharing the same infrastructure with other projects. So when designing CI pipelines, it's crucial to have in mind this resource usage, caching possibilities, and take advantage maybe of parallelization builds, etc. Whenever it's possible. This optimization helps reduce build time and improve pipeline reliability, all without increasing infrastructure cost, with a main concern for us. In conclusion, project needs fast, safe, and reliable pipeline. Fast means reducing build time. Safe and secure, because project operates in a constrained environment, as I said, and isolated environment, because that means that security, isolated environment means security, and security is a top priority as well for the foundation. And the last, reliable by providing consistent result and make our services trustworthy. With this in mind, we really hope that Develocity can provide solution to these challenges and addressing common issues in our daily life in CI for Eclipse project and for the Eclipse Foundation staff as well. Now, what about the evaluation phase? So the evaluation phase is underway. It started in January until March, with a potential extension because it's a bit short. Maybe we will move this to June. So meantime, you can access the platform even if you're not a part of this evaluation phase. So the URL is develocity-staging.eclipse.org, and you can connect with your Eclipse account. There are already a few projects involved in the evaluation phase, meaning ESCET, Graphene, Bridgeship, and Glassfish. We have a top ticket that gather all this information on the help desk. Please feel free to comment on that ticket if you have any question later and after this presentation. And if you want to be part of this evaluation phase, please create a ticket, fill the input, and we will create. We will help you to implement Develocity in your project. And what matters here is the post-evaluation phase, because we need to assess the value of Develocity for the community and for the Eclipse Foundation. So for the community, it's by gathering feedback. So that's why I mentioned to put some comments. They are really important for us. And at the end of the evaluation phase, we will send a survey, so to gather information and yeah, any information useful to assess the product. And from the Eclipse Foundation perspective, we still have to evaluate the impact on our infrastructure. So it matters a lot because it's about storage, CPU, and memories, and the effort required to maintain it with our staff. So your feedback is essential in determining whether Develocity can be valuable as a new service for Eclipse project. Now, I'll pass the floor to Gasper, and you can present. You can do the live demo. Let me just.
You can see the screen and you can hear me, right?
Right. You can
Cool.
go.
Yeah. Okay, so yeah, thanks, Sebastian, for the intro. Yeah, as I mentioned, today we're gonna be talking about Develocity. And yeah, the like I guess first question you might have is like, what is Develocity? Basically, Develocity is a data platform and an acceleration engine, and it's available for free to all Eclipse projects at develocity-staging.eclipse.org during this evaluation period, as Seb also mentioned before. And it's a platform that kind of improves the productivity of engineering teams, of developers, of both internal and external contributors by both providing insights into how the software is actually being built, both locally as well as on CI. Um, so stuff like which dependencies are used, like which versions are actually used at the end after dependency resolution, which goals are executed or tasks, depending on the build system, all of that data, as well as it's offering accelerating technologies to basically accelerate the execution of not just Gradle builds, but also Maven, Bazel, SBTMP, and Python builds. Like all of that is supported for with Develocity. Um, and how this, if we focus now first on the insights, so how these insights are provided, it's via build scans. Build scan, you can think of a build scan basically as an X-ray into your build. And it allows you like efficient troubleshooting, and it allows you to make informed decisions about what the actual pain points are, where the time is being spent, and you can use that information to make builds both faster as well as more reliable. And yeah, we give you information such as like the dependency graph, like which goals and tasks were executed, which tests were executed, the plugins applied, the switches, the environment this was executed on, CPU memory, disk and network usage throughout the build, the full console log, and much more. The neat thing about all of this is that it's linkable. So basically everything in the Velocity is you can link to it, which is super useful if you, for example, have a failure, you're not really sure what's going on. I don't know, Docker doesn't start for whatever reason. It's very easy for you to link that specific line in the console log, for example, send it to somebody who can help you without needing to copy paste the whole console log and have them search for the like information that kind of you're looking for. Um, so that's one part, and then all of these build scans, because like each build executed produces a build scan that's published on Develocity. And all of these build scans are then combined to give you some insights into like cross-build analysis. So if like here we have like four screenshots. The top left is of a trends view. So here you can, for example, show how build times evolve over time. For example, you do some changes, you're interested in whether those changes actually improve your build times or not. So stuff like that. Top right, you have the performance dashboard, which can, for example, be used to find degradations in cache performance. Bottom left is a scan comparison, where you can see like between the two scans which inputs changed. And those in turn prevent you to get cache hits. So instead of reusing the outputs already produced by another build, you need to rerun the tasks again or goals. And the bottom right is, for example, how you can find different failures, for example, on CI, why those, how often they happen, like why they happen. For example, it might be it might be that only Windows machines are affected, and that kind of gives you a really good clue what might be going on. Or maybe it's like limited to like a specific CI runner, for example, and the end result is that you find out that that specific agent has a failing disk, which is like sometimes causing your builds to fail. Stuff like that can be surfaced with Develocity. Another thing we offer is also the Develocity reporting and visualization tool, which is a platform for data exploration and analysis. You can customize these views and customize like different reporting views. Under the hood, this tool uses the local NCI build data that's available in Develocity, which is then fed into Grafana dashboards. We provide many of these pre-configured reports or dashboards, and this allows you to like do cross-project analysis. For For example, like which goal type is the most lengthy with across all of the builds, across all of the executions. And that kind of enables you to say, okay, like we can focus our time on making this faster, which will have the most impact. Just a note, this as of now isn't like available for Eclipse yet, since it's still in the evaluation phase. But it's available in general and probably would be interesting after the evaluation phase since since you have like a lot of different projects part of the Eclipse Foundation. We also are adding support for Tycho goals. A lot of Eclipse Foundation projects use Tycho both for compilation as well as for testing. Uh, and currently the tests are not surfaced, and we're adding that support in the next, probably in the next release of the Maven extension for Develocity. And yeah, we're adding that support so that the Tycho projects or projects that use the Tycho plugins can also get the benefits of Develocity. Now, if we move on to build acceleration, there are three kind of acceleration technologies that are most prominent with Develocity. The first one is build cache, which is with what I mentioned already. Basically, build cache, how it works is it computes a hash basically of the inputs. If they don't change, and that goal or task has already been executed on CI, for example, it can avoid the work of re-executing all of those things and just get the results from cache. So, for example, the compile jar, instead of running all of the compilation and annotation processing and all of that, it will just take the jar from cache. Same goes for tests. Instead of running all of the tests, which are oftentimes the kind of the most lengthy process in a build, it can just get the test reports from cache if the tests or if the source code didn't change, for example. And we're offering both local and remote cache nodes for that. Remote cache nodes are super useful for CI. Those can give you like a really good boost in CI per like build performance. The next technology is predictive test selection, which runs only the tests that are kind of relevant to the changes that you made. And it's working of a predictive model, like of a machine learning model that's using the changes and the historical data to kind of discern which tests are relevant to what you just changed or not. And it's only running those tests, skipping the other ones. And there's also a simulator functionality available to assess like whether this would make sense for your project or not. And then the third technology is test distribution, which takes your existing test suites and distributes them across remote agents to execute them faster. And yeah, these agents can be auto-scaled up and down, and that would be an opt-in feature as well. Now, the next thing is like we're just gonna go to some live demos. Whoops. Where do I have my mouse? Okay, so for example, this is a project, Eclipse Store, which is a recently joined project to Eclipse Foundation. It used to be called MicroStream. And MicroStream has already used Develocity successfully. So Eclipse Store, like this in this example, this build takes 1 minute and 23 seconds, which you might say, okay, this is like fairly good already. And this is like when it's executing, like for this specific build, this is executed like all of the goals. The same build, if we use it with cache, this can be done in only 15 seconds because 90 of the goals were avoided and because the results were gotten from cache. So everything from compile, test, compile, the actual tests themselves, all of that is avoiding. The results are retrieved from cache, and it's saving you 1 minute and 8 seconds, meaning that this build is like 80% faster than without the cache. And yeah, you might say, okay, like this is just like a perfect world example. You did an experiment, that's it. If we go to the MicroStream instance, you can see that on average, the build takes 50 seconds. Great, that's super fast. However, if you go down and look at the avoidance savings, which is the work that was basically avoided with, in this case, remote build cache, since these are all only CI builds, you can see that on average, like 10 minutes and 45 seconds were avoided. Now, because this is a Maven project, it's doing work serially, so not in parallel. The calculation is super simple. Without the remote build cache, this build would, instead of 50 seconds, take like 11 minutes and a half, which is like a huge improvement on the CI burden. Now, next thing, if we look at just like the dependency, which dependencies are in a project. This is the same project, so Eclipse Store. You have here, like you have 31 projects and 500 dependencies, which is like a lot to kind of get through manually. So for example, if we scroll down, and I've like obviously prepared a bit, and so the integration CDI4 is like one of the projects. You can see here you have like three different phases that are executed as part of the build. And for each phase, you can see like all of the dependencies that were used in there and their versions. You can also see like if dependency resolution happened, such as in this case, you can see that this dependency was requested with two versions. It was resolved as 3.1, and if you open the details page, like the details pane, you can see that the 3.1 version was requested directly by the project itself, and 302 came from two transitive dependencies. So you can also get all of that information here, and this is also searchable. So for example, you have here like all of these projects, and you're just wondering, hey, does this project use log4j? And it does, and it's super simple for you to check which version. 2.21 is like, obviously it has the fix from like the vulnerability a couple of years ago, but it's super easy to kind of check that. And as I said, if you want to send it to somebody, like all of these little chains mean that if I copy paste this somewhere, it will just open the page with the thing that I highlighted directly. So that's super easy to kind of share and ask for help. Another thing, like Sebastian mentioned, were also like CI reliability. And that a lot of the times comes down to like flaky tests. When what we consider as flaky tests is basically any test that on the same set of inputs, on the same source code, so same everything, sometimes it passes and sometimes it doesn't. So this is, for example, the Apache Kafka project. You can see they have like a bunch of builds, and you can see that there's some like really flaky tests here as well. So for example, this one is flaky like 26% of the time, and you might say, okay, like that's only taking 1.8 seconds. However, if this flakiness means that because of a test that's flaky like a quarter of the time, you need to restart the whole build, that can be a really painful thing to like to kind of swallow and to live with. And this allows you to drill like deeper into this, and you can see like they're ordered out by flakiness. Like you have some that are longer, some that are shorter. If we drill into one of those, this is like one of the classes here. You can see, okay, like it's just like, for example, these are then the actual tests executed. You can see like this first one, if I fix only that, I'll fix 10% of the flakiness of this specific test class. And so that's like a really good boost of like, this is really valuable information for you to know where to invest your time to make your builds actually better. And you can then drill deeper into, if I go into this test directly, you can see all of the invocations. So you can see like sometimes it failed because of some broker ID, sometimes it failed because of a timeout exception, and the timeout exception is the one that's flaky. So that's like maybe something to spend the time to try to improve. Similar thing, you can see all of the test failures. So this is a Glassfish project build, and you can see it executed a bunch of goals. It took like 16 minutes. It executed 3,400 tests, and there were 3 failures. And it's very easy to kind of see why it failed. Instead of going through the console log or downloading the Surefire report from CI, you can go into Develocity. You can see how like these 3 tests are the ones that failed. And if you're interested, you can go into like a specific one, and it will say, okay, like, yeah, there's a connection exception, like connection refused, which also like to me sounds like something of a flaky nature. But this is like actual information that you can use to kind of also know how painful something is for you. If we look at the failures on general, so not test failures, but just failures in general, you can see like you have this dashboard here. This is actually, this is on our solutions instance, but this is filtered by Eclipse projects that I ran experiments on before I opened the pull requests for them to connect. So for example, you have here, you have the Mojara. You can see that I got some failures because of missing dependencies or could not resolve dependencies. There's, for example, the Jetty, which like just says failure. But if we go into more into detail on that, you can see, okay, like project Jersey, some start Jetty, something failure. If I open this specific build scan and explore the failure, you can see, okay, like, so this failed because shutdown monitor already started. Um, and so this is also very important for open source projects because as a developer, you want to contribute to a project, and it makes it if like the first time you pull a project, you it fails, for example, when you try to build it, you might just say, okay, like I'm just gonna try something else. So it's like it's very important for open source projects as well. And I have one last demo of predictive test selection. So this is the Spring Boot project, and you can see here, like in the last 7 days, they could save 8 days of serial work just like with using predictive test selection, skipping the tests that are irrelevant to the changes made. And that's 45% of the kind of the test time. So this is like also like could give you like a huge boost. Um, yeah, so those are the kind of acceleration technologies. And the last one is yeah, the test distribution. I don't have a live demo of that, but we did some testing with the Eclipse Jetty project, and we could reduce the test time for that project from 47 minutes down to 16 minutes with test distribution. And with some additional optimizations such as build caching and parallel goal execution, like the overall build time could go from 51 minutes to 11 minutes. So like the huge savings are there. And if we move on to like I kind of already started on this topic, but like why is this important? So one thing is just like it gives you faster feedback cycles, which obviously it means less idle time. You have like less context switching. Um, but it also leads to more frequent builds. For example, um, if you have a build that takes half an hour to kind of build and to test, you're gonna probably just like you make a change, you push it to CI, wait half an hour, see that the test failed, even if it's like a trivial thing. You fix it, you push again, you wait for another 30 minutes to see if that worked. If you can bring that build time and test time down to like a couple of minutes, um, you're much more inclined to do the tests locally, which means you're gonna fix it much faster. You're not gonna use that many CI resources, and at the end, you're gonna have like a better developer experience as well as better productivity and like usually a better quality of the product. And yeah, as I said, like as a developer, you have multiple open source projects to kind of pick from. And the barrier to entry, if you have like a lean build, like fast, easy to troubleshoot and all of that, that's usually like a very good thing, both for internal as well as external developers, to kind of incentivize them to contribute to your project. So basically, I would like to invite you to join the Revved Up by Develocity open source program. We have like a lot of different open source both projects as well as foundations. So Apache Foundation, Micronaut, Common House, Spring, JUnit, Quarkus. So a bunch of them, and we kind of like to invite you to join the family. So yeah, as Sebastian at the beginning said, if you want to kind of try it out, please open a help desk ticket to get the project connected to Develocity. And in the meantime, you can also visit the DP University for some free training on both developer productivity and engineering, as well as Develocity in general. There's also, for example, a course on Maven caching and stuff like that. So that's it from my side, but I'd be happy to answer any questions that you might have.
Thank you. We are running out of time, but we can. I don't see any question on the chat. If anyone has a question, maybe we can open for one or two questions. If not, we'll wrap up.
So quick question. We have a lot of tests, a million each night. Did you test it with such an amount? Because I think it would replace Jenkins, and Jenkins has horrible problems with its amount.
I mean, yeah, we work with also very big projects. I think the longest test suite I've encountered or I've seen is like 2 days of testing. And this kind of cuts it down a lot. So I'd say that our answer is yes, and like the amount of tests doesn't really change the performance of it.
Okay, we have a question from Hannes.
Yes, thank you. You mentioned the build cache, and you said that as long as the source code of a project didn't change, the project is skipped and the previously built jar is reused. I think this works fine for pure Maven projects, but you also mentioned Tycho, and Tycho uses in general the concept from Eclipse PDE to have a target platform. So kind of a source of all available dependencies a project is compiled against that is not defined within the project itself. So there is a common target platform and source of dependencies that is not defined within the project. So I wonder if you're adding support for Tycho, if this is considered in the build cache as well.
So we're adding support. We're working on adding that. And yeah, in general, so just to kind of give a bit more context. So it's not just the source files that are considered as the cache key inputs. It's different parameters, different properties. Now for Tycho, we are aware that it's there's things that are defined out of like not in the POM, for example. So yeah, we're gonna like as we're working on adding support for that, we're gonna kind of need to like imitate a portion of configuration of the Tycho itself.
Okay. Yeah, because a change in the target platform can, of course, I mean, it can, in theory, or it can change the output in the jar. For example, if method signatures change, then it can, under certain circumstances, can even lead to different bytecode, or it can, of course, fail compilation because there are some incompatible changes, for example, in the target platform that are not reflected in the source code. And then I think it wouldn't be good to reuse an existing jar that would actually have led to compile error.
Yeah, of course. We're also happy, like if we're happy to work with you or with Tycho, the developers, to kind of obviously like as we had support for caching Tycho goals, we want them to be correct. So yeah, we're happy to work with you to kind of make the integration as best as possible. Yeah, but and another thing, just as I mentioned, like the difference, like Maven also with Maven 4, and it was also backported as an extension to Maven 3, also supports caching. The difference here is that Maven caching works on a project level, and the build caching that we're talking about works on a goal level. So it's actually working on like a specific goal. So even within a project, for example, if you only change the test code, it's only going to recompile the tests, not the code under test. And then it will actually obviously need to re-execute the test. But that's just an example. So it actually works within a project per goal level.
Okay. Thank you.
We have a question on the chat, but we have also an answer. So, and the question disappeared. No. Okay, if there is no other question, I think we can wrap up. And thank you for joining us. Thank you, Gasper, for this presentation. Really interesting one. The live demo, particularly, very informative. Just a quick reminder, there is some links as well in the chat about all different links. You can copy paste on your side, and yeah, definitely if you want to be part of this evaluation phase, don't feel free to create a ticket on the help desk, and we will help you to integrate your project with Develocity. Wish you all a good day. Bye bye.
Thanks. Bye.